So welcome to our next session. My name is Marina Robach. I'm from the clinical education at Align Technology. Next in line, we have something that is completely different. So it's not really about the clinical practice that you've seen, but it's another aspect that without it, we cannot live. And that's real world scientific evidence. I have here with me Dr. Francesco Mangano. He's a friend of mine, but more than a friend, he's a great researcher. He has not less than 140 publications. He's the editor of one of the top journals in dentistry, the Journal of Dentistry, with a very, very high impact factor, 4.4. He's as well one of the founders of the Digital Dentistry Society, an association that has been growing very, very fast over the last years, and he was just the past president. So welcome to our stage, Franz.
Thank you.
Warm welcome to you.
Thank you very much. Thank you, Marina. And thank you for the opportunity. I'm very happy to be back here in Palma for the exocad Insights. It's an honor. And in this short lecture, I will report you on the results of a study that we published last year regarding one of the most challenging clinical application. The study is an in vitro study where we are talking about numbers of intraoral scanner, the full arch implant rehabilitation. And the study has been published in the Journal of Dentistry last year, and basically we wanted to compare and to take a photograph of the actual situation with the current technology available in our hands. We wanted to compare traditional technology like the extraoral photogrammetry with new technology like the intraoral photogrammetry with the latest, intraoral scanner released on the market and the direct scanning. I think it was very hard work, like all these in vitro studies, because it takes a lot to make these studies. But we know that we have a problem with intraoral scanner in the full arch implant patient that is related, of course, to the stitching error. This is why companies usually suggest, the dentist suggest us to take a scan of the occlusal part, then go buccal, and then go palatal, or vice versa, and not to proceed zigzag from right to left, because they know that there is accumulation of the error. The error remains anyway, but it distributes a little bit. This is one of the main limitations of the intraoral scanner. It has been one of the main limitations of the intraoral scanner from the very beginning. The second problem, I think, is related to the difference between the mesh and the libraries, and it is something that the dental technicians know very well, because we all know that our mesh grow a little bit when compared to the libraries available in the computer-assisted design software, and it's another problem. But the stitching error has been always considered the main problem. And so we designed this study in a very simple manner. There was a model with 6 implants. We had to gather reliable data on the position of the implants in this model. So we probed it physically, because touch and probe is still the most accurate method to get reliable data from a model. And then we scanned the model in different ways, using extraoral photogrammetry, intraoral photogrammetry, and direct scanning with 4 different scanners. And we compared all the results achieved and obtained with the reference model. The reference model was the one captured by CMM, so coordinate measuring machine, using a Reni show. So we probed the model, we obtained all the reference information about the distances between the centroid of the different implants. That was our reference table. And then we captured the model using extraoral photogrammetry. That is a very well-known technology, but we used a very novel and new machine. Intraoral photogrammetry, that is a videogrammetry, a new scanner introduced in the market, and then direct IOS scanning with 4 different novel IOS. Not all of them were novel. There was also an old one because we wanted to compare the results we can obtain with novel devices with an old one. And then using a reverse engineering software, we compared the results. So calculating segment per segment along the linear path of the scanning and also along the cross distances, the errors when compared to the reference. We know that comparing so different technologies, it's very difficult because we are talking about very different technology. But now with the digital devices, we can do it easily, up to 1 micrometer error. So we can report and we can evaluate error up to 1 micrometer. And the first step, as I told you, was giving this model. You need to screw in cylinder, put in a touch and probe machine, and touch all this cylinder together, precise X, Y, Z information about the points, the position of each one of these cylinder, and together then, of course, the data necessary to create a reference model. It takes a lot of time. It's impossible to do in our patient. You can do it in vitro easily. And this is the system. It is the best system to have this model. And then I have this reference table, and I know very well about the distances between the different implants. This is our reference. And then we can proceed with extraoral photogrammetry because we want to compare extraoral photogrammetry with the reference model. Extraoral photogrammetry is a very well-known technology. It works very well, but the problem is that it requires an additional investment in another machine that you need then to combine with your intraoral scanner, because your intraoral scanner is anyway necessary to get the soft tissues for your plan, okay? But it works very well. It's a very famous technology, and recently it has become also a little bit cheaper when compared to the past, because in the past machine for extraoral photogrammetry, they could this device could cost a lot of money. Now they cost less. Anyway, it's an additional investment. We know that we need to move 45 degrees around the model. This is an example, but in real what we did on a mannequin. So the model was mounted in a mannequin to get more reliable data. And this is what the software gives to you. The software gives to you basically the reconstruction of the position of these dots, these vertical flags, and through these dots, it can really reconstruct the position of the implant, and it can recall the library of your implant and send this to exocad. Of course, this system requires also an intraoral scan, so it's an additional investment. This system that I use is 3 dots from Open Technologies, an Italian system I'm very familiar with, and it works very well and fast. And as you can see, it's the typical classical photogrammetry. There is nothing new in this. We all know that extraoral photogrammetry works very well and is very predictable. In the past, we were talking about error about 10 micrometer per segment. Here we will see it's even better with the recent technology. This is the novel technology of intraoral photogrammetry. It's a videogrammetry technology, and it's embedded on this intraoral scanner that has been recently released in the market. We are moving the flags from vertical to horizontal, but in real the technology is completely different because it's not photogrammetry. We can call it videogrammetry, and it is an interesting solution that has been introduced in the market. Of course, it requires multiple scans to be combined by the software, by the same software. So with one single machine, we can make a sort of photogrammetry that is a videogrammetry, and we can combine dentitions, flag, and align everything using the same device. And then we have the classical direct intraoral scanning. That is what I do every day in my dental clinic, because in my dental clinic, I proceed directly with direct intraoral scanning. These were the scan bodies for this case. And these were the different scanners that we tested. Basically, I captured 10 scans per each scanner, okay, complete. The model was placed inside a mannequin head to replicate the environment in the mouth of the patient, of course, without saliva and without blood. And this is the Lumina, that is the scanner that I'm using now in the last 2 years in my clinic, and I'm very satisfied by this scanner. Not only, of course, for the full arch, because I'm using it every day, but it is also a very good solution for the full arch clinically from my side. I will not talk about clinical cases, but we regularly deliver full arch based on this scan, so it is possible. The technology is different, of course. The idea to capture more, it's a very brilliant idea in my opinion, because it gives you the possibility to reduce the stitching error, and it's pretty easy to understand. 306 was amazing for me for the speed, exactly like Lumina, very, very fast scanner. If you think about scanning a full arch now, it's very easy, very fast, compared to 10 or 15 years ago. 15 years ago, scanning a full arch may take 30 minutes or 40 minutes. Now in 2 minutes, in 30 seconds, you can do it. And it's also good because speed means quality. This is the 900 by Medit, once again 10 directs, and this was the old one, because I wanted to compare also an old one with the most recent one. So all this acquisition had to be compared with the reference. So we uploaded all these different acquisition inside a reverse engineering software that is capable to understand and to compute up to 1 micrometer difference. And this is basically what we found. So this is the summary. This is the mean error per segment. What does it mean? It means that if I try to distribute the error per segment, because in our study we calculated the error per each segment, including the cross segment. But if I try to distribute all the error, because all these errors are relevant, this is what it comes out. Extraoral photogrammetry is amazing. 5 micrometer error per segment. What does it mean? That all your cases will be delivered without any issues, and all your All-on-X restoration will be passive, and they will work clinically very well. Same good results, I would say, for the new videogrammetry of our Scan Elite TPG and for iTero Lumina, because we are talking about a mean error per segment that is approximately 30 micrometers. There is not a big difference here. We are talking about high-end solutions. So with such a small error, obviously, you can deliver your All-on-X restoration without any issues, unless you make very big mistakes during the handling the scanner. But if you are an operator with minimum experience, now it is possible. So and it's interesting to see that it's possible with 3 different technologies: extraoral photogrammetry, intraoral photogrammetry, and direct intraoral scanning. Then we see the other results. Medit is also quite good, because we are talking about very little error, 50 micrometer per segment. And then the other one, as you can see, the old one is the worst, and it's not surprising. So we have an elite revealed by the statistical analysis of this study. That has been a huge study, I mean, in terms of numbers. And the elite is it's a team of 3 different technologies, because we are talking about extraoral photogrammetry, videogrammetry, and direct scanning. So it's only up to you to choose what you want to integrate in your workflow, in your clinic, because you have 3 solutions that are all extremely reliable for this challenging application, because the numbers, this is something very important, and Christian Kochman has told this morning. We have the possibility with digital dentistry to control the quality of each step in our workflow, including the scanning. That is the first step, and it's one of the most important steps because it's the first one. So we are talking about a quality control, and here we have numbers, and the numbers help us to understand all the processes. And so you have 3 options. You can go with the photogrammetry conventionally, but then you need to invest in a scanner anyway, because photogrammetry will only give you, extraoral photogrammetry will only give you the position of the implant in the space, but without any soft tissues. You can go for videogrammetry, or you can go for direct intraoral scanning, in this case with Lumina, because it works, because it is compatible with a perfect passive fit for your all-on-X restorations. So basically, what I'm trying to tell you here is that, yes, the problem with cross arch still is there, because the stitching error still is there, but the quality of the software, the quality of the algorithm, the quality of the solution provided by the company, now finally they closed the gap. So we finally closed the gap, and it's a big result. Because in the last 15 years, all the company, all the technology, we tried to get here where we are, and finally we did it. We are finally able, with a direct scan, to attain a completely passive and satisfactory passive fit full arch restoration. So, in summary, extraoral photogrammetry remains the absolute baseline. It's not the reference, because I told you the reference is touch and probe, but touch and probe is not possible in real life. It's something you can do on models, but not in real life. 5 micrometer error is really nothing. I mean, it's basically very similar to touch and probe. But of course, you need to buy this device, and then you need to invest in an additional intraoral scanner, because you need to combine both. And it's easy to combine, but you need it. This device combines both the solution of photogrammetry turned from vertical to horizontal, and the intraoral scanner, with a mean error of 29 micrometer per segment. That is very interesting. You need to make multiple scans for alignment, but it works. And this next generation scanner, Lumina, the one I'm using every day in my clinic, basically with this you can obtain the same error, a very small error per segment, 34 micrometer. It's a mean error per segment. You need to consider that the longer the distance, the more the error, and it is the concept that is valid basically for all the intraoral scanner, including the APG, but we are talking about an error that is clinically compatible with your success. So, as to summarize the results of this study, we have photogrammetry that is extraoral photogrammetry that is the best. We have intraoral photogrammetry and iTero Lumina that are basically equal, using 2 different technologies, and this is very interesting. So 2 different technologies, same results. And then we have the other scanner that they are unable, despite of the big improvement, despite of the quality that is growing everywhere, they are still unable to grant you the complete success in terms of passive fit, because there may be some problems clinically. I mean, let's consider that this is a photograph of an in vitro study, but if you translate this clinically, I expect, particularly for the non-experienced operator, a little grow in the error. Okay, not too much, a little bit for the good operator. And so, obviously, this study says modern scanner, they are filling the gap. Some of them already closed the gap, like Lumina. And we are happy of it because it was a long journey. And I was there from the very beginning, I could say. And the fact that we can do it directly without adopting multiple technology, it's really brilliant. It's really an advantage. And we have to be happy of it because, like Leonardo said, simplicity is the ultimate sophistication. And to be able to get there only with our intraoral scanner, it's a major achievement, and it's something that we need to consider in our workflow every day, because now we got the numbers to be successful with direct scanning in the holo-nix situation. Thank you very much for your attention.